So let's start the class. Let's record the important result for the triangles. Okay. So remember, if we have a triangle, right? For the triangle, and they can talk about area, but there's another important result is if this is a triangle, okay, and then for the of the interior angles is going to be 180 degree total. Okay. So most of students know that. Okay. Now, so if it's an isosceles triangle, this is the isosceles triangle. Okay. If there's an isosceles triangle, then two angles at the bottom should be the same, and this is a gamma. Okay. So in this case, the formula becomes this one. Okay. Now, my last question, equilateral triangle. Equilateral triangle. Now, for the equilateral triangle, three angles are the same, right? In this case, we can determine plus alpha, the sum of three interior angles is going to be 100 degrees. So alpha must be equal to 60 degrees. Okay? But for isosceles triangle, you cannot determine the three angles. Okay, so alpha can be very large, but clearly alpha cannot be larger than 90 degrees. Okay, because 2 alpha plus gamma equals 100 degrees. So alpha is always less than 90 degrees. Okay. So this those are the basic information we have. Okay. And about angle, we also have, we know that this is spatial angle, right? So if a strict line here, then you have alpha and the beta. This alpha plus beta is also going to be 100 degrees, right? So the angle, the flat line, okay, from two angles. So the total would be 100 degrees. So 90 degree means the line, if the line is then either both sides is going to be 90 degrees, okay? Right? 90 plus 90 is going to be 100 degrees. Okay, so we have a quick review on this. Okay, now let's try to do two problems. Okay, the first one is if you have a triangle, okay, you have this is alpha, that's beta, that's gamma. So if you know alpha to beta to gamma is going to be, okay, and 2 to 4, and it's going, yeah, 2 to 4 and 8, okay, and find, yeah, in this case, when, yeah, I'm not going to change this, just put it 1 here. Okay. Otherwise, you can simplify this ratio. So find the alpha, the smallest angle. Okay. Now, if you know the ratio of the three angles, right? The proportion, you know, alpha is proportion to beta, right? Right. This is a alpha to beta is 1 to 4. Beta to gamma is 4 to 8. It's also equal to 1 to 4. Okay. So to determine this alpha, the best way to do is, if we see the ratio like that, equation, this is the equation, then the best way to do is you express alpha as lambda, or whatever you choose a parameter. Beta is going to be 4 lambda. Gamma is going to be 8 lambda. Then you see the alpha to beta to gamma is 1 to 4 to 8. with the same lambda. Then, using the property, okay, alpha plus beta plus gamma should be equal to 100 degrees. So it'll be little lambda, which is going to be, right, 13 lambda, okay? So that's supposed to be 180 degrees by the formula, right? By the result we already know. So then you find the lambda. Lambda is 180 degrees times divided by 13, okay? So since alpha is going to be lambda, right? So alpha equals lambda. You can erase this. Oops. Since alpha is going to be lambda, so it's going to be 180 degrees divided by 13. You don't need to change it to the decimal form because this is a perfect number. Otherwise, you get only approximation. Okay, so this is answer for alpha. Okay, now the exterior angle of the triangle is defined in the following way. So this is a rotation counterclockwise. You extend this angle, and here's going to be alpha. Okay, that is going to be rotate counterclockwise always. Okay, then you extend this line, then you rotate counterclockwise, and get a gamma. So let's find out. Find the sum alpha plus beta plus gamma. Okay. Maybe you can determine, you cannot determine, we don't know. So let's try. But we know that I'm going to denote the interior angle by alpha prime. This will be beta prime. This will be gamma prime. Okay. I know alpha plus beta alpha prime is going to be 180 degrees. So alpha is going to be 180 degrees minus alpha prime, right? Beta is going to be 180 degrees minus beta prime. And the gamma is going to be 180 degrees minus gamma prime. So the sum is going to be the sum of the three. So 3 times 180 degrees minus alpha prime minus beta prime minus gamma prime. But those three I can put inside the parentheses, become plus. But alpha prime plus beta prime plus gamma prime is going to be 180 degrees. We know that. So it's a 3 times 180 degrees minus 180 degrees. It's going to be 2 times 180 degrees, which is going to be 360 degrees. Well, I'm surprised, yeah. So 360 degrees. Okay, it can be uniquely determined. All right, so next step, we're trying to extend this formula. The sum of interior angles of triangle is 180 degrees. How about a polygon, n polygon, like a 4 polygon, right? You know, something like that, right? Can you, I'm going to label it in this form, alpha 1, alpha 2, alpha 3, alpha 4, okay? Can we find the sum of them, okay? Can we find out, find out this, okay? Well, you said that, well, we don't know, right? Maybe it cannot be determined. I claim that this is going to be 360 degrees. The question is, how do you know that? Yeah, so that's right, so it's 360 degrees. Why? Right? So you can prove that using the previous result. The idea is you divide this polygon into 2, right? Okay. Yeah, it's a 2 triangles. So alpha 2 is become 2 angles, right? Alpha 4 become 2 angles. So the sum of those 4 angles is actually the sum of the 3 interior angles triangle and add another one, right? So actually, this is alpha 4 and alpha 2 can be decomposed into 2 parts. Okay, so let's call it maybe it's obvious, right? So the sum of 4 interior angle is going to be the sum of the 2 sums of the interior angle in the triangles. So that's why it's going to be 360 multiplied by 2. Okay. Now, more general, if we have an n polygon, okay, so this is called n polygon. You have n sides. Okay, n polygon, this will be alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, and so on. Okay, suppose you have n sides. I just draw alpha 6. Okay, so 6. Then the sum of the n interior angles is going to be n minus 2 times 100 degree. But you can also prove that to draw many triangles, okay? You have n minus 2 triangles, right? Yeah, you can draw, it's actually n minus 2 triangles. Fixed point alpha, then you can draw the lines, 1, 2, 3, something like that, right? So, yeah. Yeah, so you get 4 triangles. No, 5. Yeah, if you have 5, if there are 6 vertices, you can get 6 minus 2 triangles. That's the reason the sum of the all interior angles is going to be n minus times 100 degree. Okay, so it's great. This is we got this formula. Okay, so we let's look at the following problems. Okay. All right. So if we know what is the interior angle of a regular pentagon, okay, or regular hexagon. Hexagon means it's actually the 6 polygon. Okay, it has 6 sides, but it's regular means they all look similar, exactly. So all the angles are same. Okay, so let's figure it out. The sum of 6 interior angles will be 6 alpha, right? And this is supposed to equal to n, how many sides? 6 sides minus 2 times 180 degree. Right? So alpha is going to be alpha is going to be 4 times 180 degree divided by 6. So let's figure out what is alpha. So 18 divided by 6 is 3. 3 times 4 is 112, so 120 degree. Okay. Of course, you can get this in different ways. You can a hexagon. Yeah, look at the hexagon, right? Look at regular hexagon. If this is the center, you draw all the lines from the center to the vertex. Each of them is equilateral triangle. Each of them is equilateral triangle. the total here from here should be 360 degrees. Divide by 6, so it's a 60 degree. Okay? Then other two angles also must be 60 degrees. Why? Because if this is alpha, right? It forces that one 60 degrees. The reason is 60 degree plus alpha should be equal to 180 degrees. So alpha must be 60 degrees. So now you get an equilateral triangle. But then here's also alpha, right? So double of the alpha, 2 alpha is going to be 120 degrees, which is the interior angle of the hexagon. So there's another way to get the angle, okay? Yeah, a regular hexagon consists of 6 identical equilateral triangles. Okay. So for the interior angle, more angles there, the sum of the interior angle will be larger, right? You know, because it's n minus 2, right? It's n minus 2 times 100 degrees. Look at that. N depends on the number of the edges, okay? So this is a formula. If we have 5 edges, 5 angles, then the sum of the interior angles will be 5 minus 2 times 100 degrees. So n is the number of the edges. So the sum of the interior angles will be n minus 2 times 180 degrees. Now let's look at the n polygon. Look at the exterior angle. Okay. Look at this exterior angle. Okay. I call it beta 1. Okay. And maybe this is beta 1, this is beta 2, but going around. Okay. And this will be beta n. This is the beta n minus 1. So it's n polygon. All right. Can we find the sum of exterior angle? I think we can. This is the n polygon. Okay, how do you do that? This is alpha 1, this is alpha 2. So beta 1 equals 180 degrees minus alpha 1. Beta 2 equals 180 degrees minus alpha 2. And keep going, beta n equals 180 degrees minus alpha n. Yeah, because the sum of those two angles will be 100 degrees. Then you add them together. The same idea, right? Beta 1 plus beta 2 and beta 3 all the way to beta n. Then you have 180 degrees times n. You have n terms there. Then minus alpha 1, alpha 2, alpha n. Okay? But all those angles is going to be the sum of, right? It's going to be n minus 2 times 100 degrees. We already know that. In sum of the interior angles, it's n minus 2 times 180 degrees. But after calculate, this is nothing but 180 degrees. It's a 360 degrees. It's surprised. No matter how many edges you have, the sum of interior angles is still same. It's reasonable because more edges, all the angles getting smaller and smaller and smaller. Okay? Okay? So for, all the angles as so this is a useful formula. Now let's figure out the 9 polygon, 9-sided polygon, regular 9-sided. What is the exterior angle of? What is the exterior angle of a regular 9-sided polygon? Okay, so what does that mean? You have 9 sides, right? So the exterior angle is better. So what is better? I think the more edges, then the beta is smaller, okay? Because it's curved, right? So this is a beta. But we know that it's going to be 9, the sum of exterior angle is 9 beta. They're all same. This is going to be 360 degrees. So beta is going to be 360 degrees divided by 9. It's a 40 degrees. Right. If the polygon has 9 sides, then the angle is going to be 40 degrees exterior angle. So the sum of exterior angles is going to be always going 360 degrees. It's independent of the number of the edges. Okay. Here's my question. I draw the triangle. I know here's alpha, here's beta. Alpha plus beta is going to be 65 degrees. And find the gamma. Okay, can you do that? Any idea? Hello? Alan, do you have some idea to solve this problem? I'm talking about, alpha plus beta, okay? The sum of these two angles. Yeah. So alpha plus beta. I don't know the exact value of alpha, exact value of beta, but the sum of those two angles is going to be 65 degrees. Can you find the gamma? Can you determine the gamma? Okay, yes. So the idea is that I want to determine the theta, okay? So the sum of the three angles, alpha plus beta plus theta, is going to be 180 degrees, right? But the theta is going to be what? It's going to be, theta is going to be 100 degrees minus gamma. So you put it here, alpha plus beta plus 100 degrees minus gamma equals 100 degrees. Okay? So this 180 degrees canceled out. So gamma is always equal to alpha plus beta. So when alpha is plus beta is going to be 65 degrees, then you can determine the gamma. Okay? Yeah. All right, here's another one. I draw a right star, okay? Oops. This is regular star, okay? So what is alpha? Yeah, this is a regular star, all the size, 5 star. A single 60 degree. I think we can figure out, this is a regular pentagon.
Polygon?
Pentagon. So you can get the beta. Okay. So 5 beta equals the sum of interior angles equals 5 minus 3 and minus 5 minus 2 times 100 degrees. Okay. So it's going to be, so beta is going to be 3 times 100 degrees divided by 5. Yeah, let's see what is the angle. And we calculate 3 times 180 divided by 5, 108. Okay, 180 degrees. So now, yeah, so now you get beta, right? This is a complicated problem, but step by step. So this will be, look at this triangle, right? This is alpha, and I already know those 2 angles. This angle is 180 degrees minus beta, right? So it's going to be 72 degrees. Okay, this is 72 degrees. Okay, so this is 72 degrees. Now, if we know 72 degrees, how to find the beta? Alpha. So alpha plus 72 degrees plus 72 degrees equals 180 degrees. Okay, so that's why this is alpha plus 144 degrees. Okay, alpha is going to be 180 minus 144 is going to be 36 degrees. Ah. Yeah, so 36 degrees. Yeah, let's work out an easy one. Okay, so if you know this is the isosceles triangle, isosceles triangle. Yeah. If beta is going to be 32 degrees, can you find alpha? Huh? 74 degrees? Okay, yes. So the way you do is write down the equation. 32 degrees plus alpha equals 100 degrees, right? Then 2 alpha equals 180 degrees minus 32 degrees, which is going to be 48 degrees. No, 148 degrees, right? Then alpha you divide by 2. 148 degrees divided by 2 is going to be 74 degrees. Okay? Good. Okay. So this is about the angles. Our next topic is our area of the triangle. Okay. Everybody knows that. Given triangle, right? This is base, this is height. So the area Yeah. Okay, that's clear. Okay. So now we are in the coordinate system. Okay, this is x-axis, this is y-axis. And I have a this is a 4, that's a 5, and this is going to be 3 are connected. What is the area of the triangle ABC? Hmm?
Three.
3 or 1.3? 1.5. You think so? 3?
1.5.
Everyone says 1.5.
Because
Yeah, so this is a 1, the height is 3, so the area is going to be half of the base times the height. It's 3/2, so 1.5. All right, the next problem. I have a point has coordinates 2 and 1, another point B and 5 and 1, and then C 4 and 4. Okay, find the areas of this triangle.
six.
Hmm?
6.
4.5. Why is the answer different from others? You say 6. Are you working on that? How do you do that?
How did you get?
You see, you have to find the base and the height, right? So this is a, right? This is a B and the height from here to here, right? So you have to figure out B equals 5 minus 2, which is 3. H,
-4. No, 3.
H. H is going to be,
4.5.
H is going to be 3, right? 4 minus 1, which is 3. Right? So now be careful when you do the computation, okay? Then the area is going to be half times B times height. It's 9/2. Got it? So it's 4.5. So now I'm going to change a little bit, okay? Slowly change a little bit. Okay, I'm going to pull the vertex down. As A is still here. Okay, B is still, C is still here. 4 and 4. This time B is going to this side. And 5 and 0. Find the area of the triangle ABC. Huh? No. Yeah, this is a more difficult step.
Error is 4.
Huh?
4.
Any answers showed up, please? I'm going to call your names. This is difficult, okay? If you couldn't figure it out, that's fine. I'm going to show you how to do it. James Young. You cannot find the height and base directly, okay? What you can do here is to use subtraction method to solve the problem. Okay, there are many ways to do. One way to do is to draw a rectangle. Okay. Yeah, draw a rectangle. Then you get, okay. Right, so that's my hint, okay? I stop here and give you a minute. Yeah, when you're trying to solve a problem, a geometry problem, don't just focus on that particular problem. You probably should look at the surrounding area, okay, which, this triangle is surrounded by 3 nice triangle, right triangle. So you know how easy to find the area of the right triangle. So you just use a subtraction. The area is a rectangle, and minus the area of 3 right triangles. But so you have to figure out this edge length. Okay? Any different answers? Different from Grant Moore's answer. Five and a half. James Young says, okay, I believe it's true. Okay, figure it out. First of all, let's look at this edge. Okay, this side is 4. And from 2 to 5, this side is 3, right? Okay, I also want to know, okay, from from 2 to 4, this is a 2. And here it is a 1. And from 1 to 4, this side, it's not properly scaled, right? It's a 3. Okay. And this is 1. So the area of the triangle ABC is given area as a rectangle. Rectangle is 3 times 4, right? Minus is the area of the 3 triangles, the first one, the bottom. The length is 3, the height is 1. Then the one on the right, 1 times 4 divided by 2. Then the one on the top, it's 2 times 3 divided by 2. Okay, so it's going to be 12. 3 over 2 minus 2 minus 3. Okay. Okay. So 10 minus 3 is 7. 7 minus 3 over 2, which is going to be 11 over 2, which is 5.5. Great, 5.5. Okay, so let's do one more problem. Given the 3 points, A is 0 is 0, B is 2 and 1, C is going to be 3 and 3. Okay, find the area of this triangle ABC. All right, so you guys have to do that. Henry, can you try? I saw your name here. Sophia, Henry, Grant, Andy, yeah, Amy. Yeah, first of all, you plot them, sketch the triangle, right? Then you try to draw addition lines. So then use a subtraction to solve the problem. Okay. So this is A. 2 and the 1 is here, 1, 2. Okay, and the 3 and C, and just, yeah, that's called C. Right, this is a triangle. How do you do that? I suggest to draw those 2 lines, one from here, the one from here. Okay. And this side from here to here is 2. This is from 2 to 1, and from 1 to 3 is 3, and this is a 1. Okay. So you can, the area of the triangle ABC is going to be the area of the larger triangle. Okay. Subtract the area of trapezoid and area of the small triangles. You don't need to use a rectangular box to cover this triangle. Okay. So the area of the larger triangle will be 3 times 3 divided by 2. Okay. Minus the area of the triangle at the bottom. 2 times 1 divided by 2. Then I have to subtract the area of the trapezoid, half of 1 plus 3 divided by 2, and multiply by 1. That's it. Okay, so it's going to be 9 over 2 minus 1 minus 2, so minus 3. So it's a 3 over 2, which is 1.5. Great. Good job, Grant. Okay. Okay, let's do an easy problem. Find the area of the triangle ABC. A is going to be 1 and 1. B is going to be 3 and 1. C is going to be 2 and 3. Okay. Two. Okay. Andy, are you working on that? I haven't heard anything from you yet. Are you there? Oh, thank you for response.
I think it's 2.
Yeah, so draw the picture, right? And you put A here, that's A is right, 1 and 1. And B is 1, 2, yeah, 1, 2, 3, and that's a B. C is a 2, 1, 2, 3. So what you get is a triangle. It's pretty good in a good position. Okay, the AB is horizontal. Yeah, AB is horizontal. So it's easy to find height. Can you see that? Right? So if this is a B, this height is H, then B is going to be 3 minus 1, it's 2. H is going from 1 to 3, 3 minus 1 is also 2. Okay? So the area is half of the B times H is half of 2 times 2, which is 2. All right. So the next one. Find the area of the triangle ABC. A has coordinates -2, -1. B is going to be 2, -3. C is going to be 1 and 3. Wow. I wish one of you can give me the answers. All right, maybe I can help you to draw the picture. Yeah, you should use a graphing, called graphing paper, okay? So -2, -1, it's here. Okay, and the 2 and the -3, 1, 2, 3, that's a B. And then the 1 and the 3, 1, 2, 3, that's a C. Aha. Whoa, that's in very irregular position. Let's work out together. Okay, how do you solve the problem? This time, maybe you use the smallest rectangle which can cover this, this triangle, right? Then you just use subtraction because this triangle is surrounded by 3 triangles, right? 3 right triangles, so use a subtraction. So this, let's figure out this side. From -2 to -2 to 2 is 4. From -3 to +3 is 6. From 1 to 2 is 1. From -2 to 1 is going to be 3. From -1 to 3 is going to be 4. And from -3 to -1 is 2. So 2 plus 4 is going to be 6. So you get all the 3 sides. Okay, so someone already gave me the answer 11. Let's try. So area is going to be area rectangle, 4 times 6, minus the area of the small triangle at the bottom, minus the area of the triangle on the right, minus the area of the triangle on the left top. Okay, and then simplify. Aha. So 11. Great, it's 11. So now you get a pretty good idea how to use a subtraction to find the area. Okay, Henry says, I think. In mathematics, you don't make a guess, okay? You should say, definitely, this is what I have. All right. All right, so let's look at the very challenging problem. I have something like that. Okay, let me put the points here. 0 and 2. 2 and 4. No, 4 and 2. Sorry, it's horizontal. And that's going to be, just assume 3 and 0, okay? So can you find the line such that this line divide the region into 2, divide this, this is a trapezoid, right? Divide this into 2 regions of equal area, okay? So this, yeah, find the line. Let's say find this x. This is x and 2, right? Find the x such that both sides have an equal area. Both sides have an equal area. Aha. Who can solve the problem? Get a candy. All right, so you know that, right? If the line is always going through the origin, and you have to justify the point. So move the point a little bit. So eventually you can get two regions of equal area. But if it passes through the vertex, then I think the triangle at the bottom is as small as the area of the triangle at the top. Yes, that's why you have to make sure x is less than 4. The reason is, they see, look at that, right? The top one, the triangle, the area is 2 times 4 divided by 2. But the bottom one is a 3 times 2 divided by 2. It's a 3. So definitely you have to move the point to the left a little bit. So you have to find x between 0 and 4, so that this line is going to divide the region in 2 regions of equal area. So please do it. This is actually a very simple problem, but if you know how to do it. Wow, Grant Moore, you can answer. I'm not sure this is the right answer. Andy, you are very silent today. Amy and Andy. Alan, they all begin with A. So I need answers from the students. Either of you give me the answer, okay? Alan, Amy, and Andy. James give me 4. James says 4.
3.5. 3.5.
3.5. Okay, Amy, you don't follow that. It's okay. Can you? I can send you the link of my record lecture and listen again. Okay, make sure you do understand some of that.
Smaller than 4.
Yeah. Yeah. Anyway, everybody already got a set of 80 problems. Trying to finish half of that this weekend. Then you have another week for other 40 problems. Okay. Alan says maybe.
3.5.
We got 2, 3.5. How it is possible? Okay. So think about this trapezoid. What is the total area of the trapezoid? Total area of the trapezoid, okay? Like I'm going to label it A, B, C, D, okay? This is the E. So A, B, C, D, okay? Is going to be the base. It's a 3, the sum, 3 plus 4 times 2, which is 7, right? Yeah, 7 is the total area. So this line is going to divide the region into 2 regions of equal area. So 7 is half of that, right? Half of the total area is going to be 7/2. Okay. Then the area of the triangle is going to be the area of the triangle AED, the top triangle, is supposed to be 7/2, right? So what is that area? That area is the height, the base is x, the height is 2, and divided by 2. So this is just x, right? And this is supposed to be 7/2, so x is going to be 7/2, which is 4.5, or 3.5. Okay. Great. Good luck. All right. So see you next week. See you very coming. Yeah, in 5 days. No, in 1 week. In 1 week. Okay.
Actually,